All right, so we've been talking a lot about features of polynomials. Now, part of why we want to understand those is so that we can understand graphs of polynomials. So we need to understand more features of polynomials to understand the graphs of the polynomials. All right, vocab and notation. So some vocab. Increasing intervals. We have seen increasing intervals. We talked about them in our quadratic functions unit, but remember a quadratic function is also a polynomial. So an increasing interval is describing as the graph goes from left to right, which is saying the x values are going up. The height of the graph, which is the y values, are also going up. So that's what we mean when we say increasing interval. Decreasing interval is as the graph goes from left to right, which again, that just means the x values are going up. The height of the graph, the y values, are going down. A relative maximum is a point where the polynomial changes from increasing to decreasing. A relative minimum is a point where the polynomial changes from decreasing to increasing. Think about this from, again, our quadratics unit, where the maximum or the minimum was the vertex, and it just had to do with which direction is the parabola opening. Well, with polynomials, we can have polynomials that turn or change direction multiple times. So we can have multiple maximums or minimums. We don't call them a vertex anymore then. And then this is a notation that we really need to understand. So when we see f of x is greater than 0, remember f of x is the same thing as y. So this is saying y is greater than 0. So that this is representing an interval where the graph is above the x-axis because it's saying that the y values are positive. This notation, f of x is less than 0, is telling us that this is the interval or intervals where the graph is below the x-axis. So our y values are negative. A couple other things I would point out on this slide is the fact that multiple things here are intervals, right? So that means that the answer to each of these is going to be an interval, where we use our interval notation, where we have our parentheses and our brackets. All of these are actually just going to be parentheses, and we always read them from left to right. Whereas the max or the min is a point. So that's going to be an x and a y coordinate together. Okay, let's see this in action. So here I have this graph, right? Looks like a parabola. Most likely it's a parabola. Doesn't have to be a parabola, but it's definitely a polynomial. So the first thing, max and min. There is no maximum. Whoops. So this, we're going to write none. Don't leave it blank. Don't write 0. Write none. Min is what is the lowest point. So the lowest point is right here. Right, that is at 1, 2, 3, negative 4. So the min is at negative 4. I'm sorry, is at 0, comma, negative 4. 0, comma, negative 4. Coincidentally, the y-intercept, that is not always going to happen. Increasing intervals. So remember, increasing is as I go from left to right, the graph is going up, or the y values are going up. So the increasing interval is going to be from 0 to infinity. I'm going to do the decreasing interval, and then I'm going to emphasize something. So hold on a sec if you're confused on that. The decreasing interval is as I go from left to right, where's the graph going down? So that is going to be from negative infinity to 0. So what I want to emphasize, using my fun highlighter, is that this 0, and this 0 are all related. So remember, when we talk about our definitions over here, a minimum is a point where the polynomial changes from decreasing to increasing. And so the polynomial is decreasing, we hit the minimum, and then we increase. The x coordinate of the minimum is going to be where that change occurs. So the interval here is representing, remember, increasing and decreasing intervals are always representing x values. So from x being 0 until we go to the right forever, which is infinity, the y values are increasing. From x going to the left forever, which is negative infinity, until we get to an x value of 0, the y values are decreasing or going down. The same is going to be true when we answer these. We are going to answer them with intervals, because remember we highlighted interval. And the intervals are going to represent x-coordinates, because what we are doing is describing what are the y values doing on those x-coordinates. So first, we want to figure out where is f of x greater than 0. And remember, that's saying where are the y values greater than 0. So if I look at my graph here, I can see that the y values are greater than 0 here and here. And remember, I want to answer that in terms of x values. Now what I have to use are the x-intercepts. So I have an x-intercept here, and I have an x-intercept here. Where are those located? This, we're going to say, is at -2, 0, and this is at 2, 0. I'm pointing that out, and actually I don't like the yellow, sorry. So I'm pointing that out because that is going to be where the intervals change. So f of x is greater than 0 from negative infinity to -2, and from 2 to infinity. F of x is less than 0 here. And so that is from -2 to 2. And now again, we want to make sure we understand this is the interval starting at an x value of -2 and including and going up to an x value of +2, but not including the 2. Sorry, I said that was kind of confusing. So we're starting at -2, then we go up to +2. We don't include either of these values, but what I meant by the including part was we include everything in between them. That's what the comma is telling us. So from -2 to +2, but these are x-coordinates. Here, this should match up, right? So since this is a polynomial, it is either increasing or decreasing. So since this stopped, and it is either, and also it is either above the y-axis or the x-axis, or it is below the x-axis. That's what we're talking about here. This was the increasing, decreasing, which also matches up. So since it was above the x-axis until -2, then starting at -2, it's below the x-axis until +2, and then at +2, it's back above the x-axis. That's what this is telling us. Okay. Let's see the next one. We're going to do this together as well. Here, so let's just jump right into it. We have two maximums. So we have a maximum here and a maximum here. Those are maximums because the function is changing from increasing to decreasing at both of those. So I'm going to write those as points. This is the point -3, 2. And then I also have the point 2, 1. I also have two minimums. Here, whoops. Yeah. Here and here. And so those are at -1, -3, and 4, -1. So where is the function increasing? The function is increasing here, here, and here. So if I write those intervals, that is from -infinity to -3, -1 to 2, and 4 to infinity. The function is decreasing then here and here. And so it is decreasing from -3 to -1 and from 2 to 4. I'll come back and explain this in a second if you're confused. The function is greater than 0. Actually, let's explain that now, because I have this nice color coding, and I'm going to change that in a second. So anyway, the function goes from -infinity to infinity. That is the entire domain. All polynomials have a domain of -infinity to infinity. So again, these are changing from increasing to decreasing at the x coordinates of the minimums and maximums. So from -infinity to an x coordinate of 3, I was increasing. From the x coordinate, -3. From the x coordinate of -3 until the x coordinate of -1, I was decreasing. From the x coordinate of -1 until the x coordinate of +2, I was increasing. From the x coordinate of +2 until the x coordinate of +4, I was decreasing. And then from there until I went to infinity, I was increasing again. So that's where those are coming from. These are all x values. Again, they all connect, because where I change from increasing to decreasing, that has to connect, then decreasing to increasing, increasing to decreasing, and decreasing back to increasing. And those all relate to the x coordinates of the minimums and maximums. All right, now where are we greater than 0? So we are greater than 0 here, here, and here. So that is going to be, again, x values, -4.25 until -2, 1 to 3, and 4.75 to infinity. So I'm using the x coordinates of the x-intercepts to identify where we are above or below 0. So I'm just looking at all of my x-intercepts. So then I'm below 0, where the graph is below the x-axis, here and here. Right? And again, these have to connect with the x coordinates that were above. So we're going to go from -infinity to -4.25, from -2 to 1, and from 3 to 4.75. So those are the x coordinates of where I'm below the x-axis. All right, I want you to try this one on your own. And we haven't seen this yet, but when we say describe degree or describe the leading coefficient, all we're saying for the degree is it even or odd? And for the leading coefficient, is it positive or negative? So try and do that, but then I want you to identify the increasing and decreasing intervals as well as the maximum and minimum. Notice that the x-axis is right here, actually. And so this is -5, if that helps. Pause the video, unpause when you're ready to check. Okay, so from the end behavior, I know it's going down to the left and up to the right. And so that tells me that the degree is odd and the leading coefficient is positive. Now I identified this is going to be a relative maximum. That's at -220. This is a relative minimum, which is at 1, -7. And then I use those to find my increasing and decreasing intervals. So it increased from -infinity to -2, and from 1 to infinity, and it decreased from -2 to 1. I would also point out that even though minimum and maximum were actually lines below increasing and decreasing, I found those first. So we don't always have to go in the order in which things are listed.